Hello everyone, I welcome you all to the TriSec Institute, and today we'll be discussing the end-term examination 2014 BTech 4th semester, and the subject is Communication Systems. So we'll be going through each of the questions irrespective of the choices that we have. And our very first question is that express the equation for the total power of an AM signal and plot the graph allowing the variation of sideband consumed when the modulation index varies from 0 to 100%. So first of all, in this question you have to write the general expression of the AM signal. So you have to calculate carrier power and sideband power, and the total power of the AM wave is calculated by sum of the carrier power, that is PC, and sideband power, PS. Okay, so you have to calculate the expressions for both the carrier power and sideband power, and then you have to sum up to get the total power P. Okay. Next question is that you have to explain the method of calculating transmission bandwidth with significant side frequencies of wideband FM signal. So here you have to calculate the transmission bandwidth by using Carson rule, and you need to present it mathematically as well. So we represent the Carson rule by B is equal to 2 delta F plus 2 FM, okay, where FM can also be treated as 2 delta F divided by beta. Now here delta F is frequency deviation and beta is the modulation index and FM is the modulating frequency. And also you have to consider the case of pure wideband. Okay. Our next question is that you have to state and explain the sampling theorem for low band power signal. So in this question you have to explain the Nyquist-Shannon sampling theorem. You have to give the brief definition of the theorem, and then you have to represent it mathematically as well. Okay. Now in the next question we are given a signal that is MF equals to 20 cos 2000 pi plus sine 2000 pi t. I'm sorry to say, but we were not able to retrieve the exact question, but here we have to calculate some values like modulating frequency, okay. So you have to calculate FM over here, and that is 1000 Hertz. Also you have to calculate Fx, that is twice of FM, and that will be 2000 Hertz. Okay. Our next question is that you have to distinguish between the modulation index of frequency modulation and phase modulation. Now here you have to create a difference with respect to the frequency deviation in both the cases, that is frequency modulation and phase modulation. And also if we look at the differences, we have to create a difference with respect to the frequency sensitivity and phase sensitivity. For the expressions you can refer the book and you can look over the internet as well. Okay. Our next question is what is AWGN channel, and explain the significance with two important properties. Here AWGN channel is additive wide Gaussian noise channel, that is a communication channel which is assumed to have two important characteristics. So first is that channel is linear, and the second is in regards to the channel noise. Now channel noise is the sample function of zero mean wide Gaussian noise process, and the reason for the second assumption are that it makes receiver calculation tractable, and also it is a reasonable description of the type of noise present in many practical communication systems. And for further detailing you can refer the book as well. Next question is list out the three vital properties of entropy of the source. So first of all you have to define what entropy is. Okay, so entropy of any source X with m different symbols, where xi, that is having each probability of pxi, you have to express it in the equation form, and the symbol that we use for the entropy is h. So we treat it as a polynomial function, so we write hx. Okay, so if one symbol has probability px is equal to 1 and all other symbols have probability 0, then hx is equal to 0. And if all the symbols have equal probability, then px is 1 by m and Hx is log m base 2. If none of the above condition hold, then Hx lie between 0 and log m base 2, not including 0 and log m base 2. Okay, and if the average chord word length we have, then L lie between Hx and Hx plus 1. Our next question is, mention two practical communication systems for the following modulation system, that is amplitude, frequency and pulse code modulation. So for amplitude modulation systems, we have commercial TV video signals and AM radio broadcast. For frequency modulation, we have FM radio broadcast and commercial TV audio signals, and for pulse code, we have digital audio video recording and playback systems and CDs, DVDs and Blu-ray digital formats. With this we end our first question. Moving on to the unit 1, we have two questions. In second question we have our first part as explain the method of generating DSP-SC signal and also plot the DSP-SC signal in time domain and frequency domain. So first of all you have to explain what is DSP-SC. And DSP-SC is double sideband suppressed carrier modulation. This is a form of linear modulation that is generated by using a product modulator that simplifies the message signal by multiplication, and it multiplies the message signal by the carrier wave. And for the expression you can refer the book, and also you have to draw the block diagram of the product modulator. Now in the second part you have to plot the DSP-SC signal in time domain and frequency domain. So for that you have to refer the spectrum of the baseband signal and spectrum of DSP-SC modulated wave. For that you can refer the book or the internet. Next part, show that SSB signal can be demodulated by the synchronous detector of the figure given below by sketching the spectrum of the signal at each point. So in this case, as you can see, we are already provided the diagram over here. So here you have to describe the synchronous detection technique. Okay, so here the baseband or the modulating signal can be recovered from the SSB-SC signal by using the synchronous detection technique, and this detection technique involves the multiplication of the received SSB-SC signal with the locally generated carrier. Okay, and you have to write an output equation. That for that you can refer the book. It is represented in the form of ET. Okay, also you have to sketch the spectrum. So here you can sketch the spectrum with respect to time domain and frequency domain. Moving on to the question 3, we have to explain the method of detecting PWM and PPM waves at the receiver. So first of all, PWM is pulse width modulation and PPM is pulse position modulation, and both of these modulation techniques are a type of analog modulation. In PWM the width is varied and amplitude and the position of the pulse is constant, and in PPM the position is varied and width and the amplitude is constant. Okay, so you have to describe the detection technique over here that is used for PWM and PPM waves at the receiver. For PWM we have a device and a method to detect the wave, and also for PPM we have a method and device. For that you can refer the books. Next question is that we have to derive the expression for transmission bandwidth of the TDM signal. So to obtain the transmission bandwidth of a TDM signal, we first have to obtain an expression for the signaling rate, that is R, and then you have to make certain assumptions for the input signals and also for the maximum frequency for all the input signals, that is FM. And as per the Nyquist criteria, you have to follow the criteria for sampling frequency. and correspondingly you have to calculate the minimum transmission bandwidth of TDM signal. With this we end our unit 1. For the phase discrimination technique, it uses a phase shift circuit and it converts the instantaneous frequency variation into phase shift and maps the changes in the phase accordingly. And for the further detailing you can refer the book or in the internet. Next part is, given the angle modulation signal, ST is equal to 10 cos 2 by 10 to the power 8t plus 200 cos 2 by 10 to the power 3t, and you have to calculate the bandwidth of the signal. So for that, first of all you need to find the general expression for the angle modulated signal, and the expression that has been given you have to compare it. You have to calculate the maximum frequency deviation, that is delta f, and as bandwidth is calculated by manipulating delta f and fm, that is modulating frequency, so it will be easier to calculate the bandwidth using the dimensions that we have given in the expression. Moving on to the question 5, the A part, the PDF of a random variable x is given by fx equals to k e to the power minus ax ux, where a is a positive constant, and determine the value of constant k. So as we are already given an expression for the PDF, that is fx equals to k e to the power minus ax ux, so you have to look for the properties of the PDF, and as for the property of the PDF we have to integrate the fx function. That will give me the answer 1. Okay, so minus infinity to infinity I have to integrate fx with respect to x, and that will be is equal to 1. Then substitute the expression that is given, k e to the power minus ax ux, and calculate the value of k by solving it like in maths we solve. Okay. Next is, what is the power spectral density, and give its property. So PSD is defined as frequency domain plot of power per hertz versus frequency, and for the properties you can refer the book. We have 4-5 properties, like power PSD is real valued and non-negative for all the frequencies, and also we have a power transfer theorem for which you might have to give a proof. Okay, with this we end our unit 2. Moving on to the unit 3, we have our question 6, and the very first part is differentiate PCM and DPCM signal generation and draw the relevant waveform in each of the case. Both the signal generations are used to convert analog signal to digital signal. So PCM is pulse code modulation and DPCM is differential pulse code modulation. In differential it actually uses the baseline of PCM, and also it has some additional functionality as compared to the PCM. For the relevant waveform you can refer the books or look over the internet. Next part is, explain the effects of slope over distortion and granular noise in the case of delta modulation. So for this question, first of all you have to draw the slope for distortion and granular noise, that is in the case of delta modulation, and for each dimension you have to describe the effect. You can refer the book for the same. Moving on to the next question, explain the generation and detection of QPSK signal with the relevant waveform. So here you have to draw the block diagram, and here input binary sequence is first converted to bipolar non-return 0 line format, and then the demultiplexer divides the odd and even bits into two different sequences. These odd and even sequences are then modulated by quadrature shifted carriers and then added to give final QPSK signal. For the complete process you can illustrate it using waveform. For that you can refer the book. Moving on to the next question, we have state an explain the condition for maximum output SNR of a matched filter. So for this question you have to consider a system with the known input, an impulse response and an additive wide Gaussian noise of mean 0 and power spectral density N0 upon 2, and correspondingly you have to calculate the largest output signal to noise ratio with reference to the sampling time. So for sampling time you have to consider a case where small t is equal to capital T, and then you have to evaluate the output average power of noise, and then you'll obtain the expression for which you will be using Squar's inequality for the numerator, and then you have to calculate the maximum output SNR. With this we end our unit 3. Moving on to the unit 4, we have 2 questions. So question number 8, what is the mutual information, and explain the properties of mutual information. Now this question is quite direct, so you can refer the book for the definition and the properties. Next question is, consider a source X that produces 5 symbols with probability 1 by 2, 3 by 4, 1 by 8, 1 by 16, and determine the source entropy. So for this you have a formula for the entropy Hx equals to summation of probabilities and log 1 by px. Now here we have 5 probabilities, so our value for the summation will be from I is equal to 1 till 5. Okay, and you have to calculate the value for the Hx. Our last question, state and explain the channel capacity theorem. So for this, according to the channel capacity theorem, in a channel which is disturbed by a wide Gaussian noise, the maximum information transmission rate is C bits per second, or you have to write the expression for it, that is C is equal to B log 1 plus S by N, where S is the signal power, N is the noise power, and channel bandwidth is calculated in Hertz. Okay. Next is encode the following bit stream using LZ algorithm and recover the original sequence. So here we have to assume that the binary symbols 0 and 1 are already sorted and stored in that order in the code book. So you have to calculate subsequence stored and data to be passed. The encoding process begins at the left, and with the 0 and 1 symbol that are already stored, the shortest subsequence of the data stream encountered for the first time and not seen before is 0 0. So we write 0 1 0 0 in the subsequences stored. Then you have to calculate the second shortest subsequence not seen before is 0 1. Okay. So the sequence of subsequences will become 0 1 0 0 and 0 1. Then you have to find the next shortest subsequence, and similarly will continue it until the given data stream has been completely passed, and finally we get the code book of binary subsequences. So we'll be showing it row by row. So first it will be numeral position, then subsequences, then numerical representation, and then binary encoded blocks. So with this we end our discussion over the end-term examination 2014 for communication systems. I hope you will be able to write the proper answers. So this will going to help you how to solve an examination paper and what to write in an answer.